Hello and welcome to Chapter 7, Section 6. We are starting our study of polynomials. Now, a monomial means one term. And the term is a number, it could be a variable, it could be a product of a number and a variable, anything like that. And by one, they mean it has whole number exponents. So this includes numbers like x and 5 and 5 times x to the fourth and things like that. But not fractional or negative exponents. And polynomial then means many terms. This is the sum or difference of a bunch of different monomials. Now, very few people ever use the term monomial, but polynomial gets used all the time. Another term I need you familiar with is the word degree. That is the sum of the exponents. And constants, a constant has a degree of 0. So let me give you some examples. So the question is going to ask us to find the degree of each monomial. Here we have negative 2. A squared b to the fourth. So we're looking at the exponents when we talk about the degree. It's a monomial because there is only one term. There is nothing being added to or subtracted from this. This is one term, negative 2a squared b to the fourth. All of this is a product of everything together. So when we find the degree of it, we're looking to find the sum of all of the exponents. So A's got an exponent of 2 and B has an exponent of 4, and so the degree of this monomial is 6. We really are just adding up the exponents. The number 4 has no variable. So essentially you could say this is 4 times x to the 0, because x to the 0 equals 1. And so because x to the 0 equals 1 and x to the 0 has a degree of 0, because 4 does not have a variable, this has a degree of 0. All constants, which are just numbers without variables, all constants have a degree of 0. Here we have 8y. Now this y actually is y to the 1. There's one y there. So our degree here is going to be 1. Okay? That's for monomials. Now the polynomials have slightly different rules. This, when we try and find the degree of a polynomial, it's the term with the greatest degree. So here we have two terms that are one's being subtracted from the other. And this one has a degree of 1 and this one has a degree of 5. So it's gonna take the degree of the highest exponent. So this whole polynomial, has a degree of 5. It's going to take the highest one. This one, here I've got a degree of 0. Here I've got x is 1 and y is 1, so this is 2 total. Here I've got x is 2 and y is 1, so this has 3 total. So this has a degree of 3 because of this term here. 6 times x to the fourth plus 9x squared minus x plus 3. This is 0, this is 1, this is 2, this is 4, so we're going to take that fourth degree there. So you're going to try some of these yourself. Please, on page 496 and 497, do check it out numbers 1 and 2, just so you get a little practice doing this and seeing what it's like. Okay? Pause here, come back when you're done. Check it out, number 1 has a degree of 3, 2 plus 1. This is a degree of 1, this is a degree of 3. Number 2, this has 1 and 0, so it's a degree of 1. This has 5, this has 5, this has 4, this has 0, so it's a degree of 5. When you have polynomials, we usually like to write them in standard form because it's easier to correct when everything is in the same order. And that means the terms go from the greatest degree to the least. So you're going to pick the greatest single variable degree that you have. You're going to put that one first, and you're going to use that variable to count down smaller and smaller. For example, if we use this problem as an example, my first variable is an x, my highest degree is an x. So if I were to put this in standard form, I would start with x to the fourth, and I would bring the sign negative x to the fourth, and then x to the third, and that's a positive number, plus x3, y2. Then this one, plus x2, y3, and then that one's last, plus 2. This is now written in standard form. We picked the one with the highest degree, the first one we saw, so we can't pick y because y comes second in some of these. The highest one, and we counted x's down until we got to nothing. This is called standard form. Now, if you write it in a different order, it's not wrong. It's just harder to sort through when you're correcting it. And as you get into college math, they will start dinging you for not seeing these details. So try and get in the habit of noticing standard form. The other term we want you to be familiar with, the coefficient of the first term, is called the leading coefficient. With our example here, this number that comes before the very first variable is going to be our leading coefficient. And remember, when there isn't a number, that number is 1. So our leading coefficient in this one is going to be a -1. So you have a series of problems that are going to give them to you, and they're going to ask you to put it in standard form and name the leading coefficient. So in this example, our variable is c, and we're going to start with the biggest one. We're going to put that one first, and then c3, and we're going to bring the positive and the coefficient with it, then c2, and then c0, essentially. And then we're going to identify that the leading coefficient is 5. Okay? Let's do some of these together. Here my variable is x. My highest degree is x cubed. So we're going to start with -4x3, and I'm done that, so I'm going to put a line through it. Then x squared is next, so -x squared, and then x to the first power, plus 20x, because this is a positive number, and then plus 2, and that leaves my leading coefficient to be -4. Here's another one. Y, we're going to start with y5 plus y3 plus 4y, and my leading coefficient is 1, because there isn't one here. Okay? Try writing polynomials in standard form and identifying the lead coefficient in Check It Out number 3, A and B on page 497. Pause here, come back when you're done. So here we have x to the 5th is going to be first, and then x cubed, and then x squared, and then no x, and our leading coefficient is 1. Here we have y to the 8th, and y to the 5th, and y to the 1st, and our leading coefficient is -3. Some polynomials have special names, and it's a good idea to become familiar with these. The first part of the name is based on the total degree. So if you don't have any variables at all, then that's just a constant, and an example of that is 4. If you do have at least one variable, but with no exponents at all, that's called a linear equation. And an example of that would be 3x plus 1. If your highest degree is squared, that's called a quadratic equation. We use this often for the rest of the year, so hold on to that name. If your highest degree is 3, then it's called a cubic. They also go to 4 and 5 in your book. 4 is quartic, and 5 is quintic. That's on page 497. The second word in the name of the equation is based on the number of terms. If it's got one term in it, it's a monomial. That's like 4x. If it's got two terms, that's called a binomial. 3 terms is a trinomial, and then if it's more than 3, it's called a polynomial, which just means how many terms are there added and subtracted together. Okay? So it's going to ask you to come up with the name for some of these equations. So for example, we're going to look at 5x minus 6. The highest degree here is 1, and the number of terms is 2. So it's going to ask you to look back at 2 terms, and 2 terms is called a binomial. And a first degree is called linear. So this is a linear binomial. Here, our highest degree is 2, and the number of terms we have is 3. So this is going to be a quadratic trinomial. And here, our highest degree is going to be 7. And we have 4 terms. So we're going to call it the 7th degree, because it doesn't get fancy after 5. It's a 7th degree polynomial. Try this yourself on page 498. Check it out, number 4. There's 3 there to try. Pause here and come back when you're done. So 4a goes up to the 3rd degree. That makes it cubic. And it's got 4 terms, which makes it a polynomial. B has no variable, so it is a constant, and there's only 1 term, so it's a monomial. C goes up to the 8th degree, and there are 3 terms, so it's a trinomial. Please make sure to ask if you have any questions. Our word problem for this section is about physics. A firework on page 498 is launched from a platform 6 feet above the ground, 6 feet above the ground, at a speed of 200 feet per second, and the firework has a 5-second fuse. The height of the firework is given by the polynomial negative 16t squared plus 200t plus 6, and it tells you that it's a 5-second fuse, so t equals 5. Now it gives you this in the problem. You're never going to have to come up with that kind of thing on your own based on this kind of word problem, so don't worry about that. What I need you to do is be able to work with this. It's telling you that t equals 5, so what I'm going to ask you to do is substitute 5 in for the t's in this section, and realize that the 5 is squared, but the 16 is not squared. That square is just on the 5. So this is really negative 16 times 25 plus 200 times 5 plus 6. So we're going to get negative 400 plus 1,000 plus 6. And that's going to give us a total of 606 feet above ground. And that's what it's asking us to do. Given t, solve the equation. Now, check it out. Number 5 gives you a very similar problem to this. I'd like you to have a little experience with this on your own so you can gain confidence in all of this. Please pause it here, try that problem, come back when you're done. So here it gave us 400 in this spot, and the 25 and the 5 stick around. So now we have negative 400 plus 2,000 plus 6, and that gives us a total of 1,606 feet above ground. Your homework for tonight starts on page 499. I'm asking you to do numbers 27 through 58 all. A lot of these are very simple. It's look at the problem and just write down an answer. So this should go relatively quickly. Please make sure you ask any questions in class while I'm standing there. Okay? Thank you much.